Dear students, in this class we are going to discuss one problem in maxima and minima in the unit 2 functions of several variables. See the question: find the maximum value of x square plus y square plus z square when x plus y plus z equal to 3a. So here some condition is given, that is x plus y plus z equal to 3a is given. We can see the solution for this. So here we are going to find the conditional minimum value of, here already mentioned that we have to find the minimum value. So conditional minimum value of x square plus y square plus z square subject to the condition x plus y plus z equal to 3a. Take it this as equation number 1. Now using this equation number 1, what is equation number 1? X plus y plus z equal to 3a. Then we can rewrite this equation as z equal to 3a minus x minus y. That means it is the function of 3 variables. It is a function of 3 variables. We convert this function of 3 variables into 2 variables for our convenient. If you are substituting that z equal to 3a minus x minus y, the given function will becomes f of x comma y, that is x square plus y square. The z square is then in the z square, substituting 3a minus x minus y whole square. To find the maximum and minimum value, what is the necessary condition? Fx equal to 0 and Fy equal to 0. These are the necessary condition. So for that, first we have to find the first order partial derivatives. What are the first order partial derivatives? Dou f by dou x, that is we can write that as fx, f suffix x. So what is fx here? When you are differentiating with respect to x partially, keep it that y as constant. So when you are keeping that y as constant, x square differentiation is 2x minus 2 into that y square is 0, 2 into 3a minus x minus y. Once again, if we are differentiate 3a minus x minus y, we will get minus 1. So in front we are multiply with minus here. Similarly, we can find dou f by dou y. Dou f by dou y is 2y minus 2, 3a minus x minus y. In case the function is like a same function or homogeneous function, if you are differentiate with respect to x, then you have to, when you are differentiate with respect to y, just you have to change that x to y and y to x here. So we will get that fx equal to 0, fy equal to 0. What is fx equal to 0? Fy equal to 0 here, 2x plus y equal to 3a and x plus 2y equal to 3a. Solving these two equations, we get 2x plus y equal to 3a, 2x minus plus 4y equal to 6a. That means there are two equations are there. That is, we have to multiple with 2 here. If you are multiple with 2 here in the third equation, we will get the 2x plus 4y equal to 6a. Then we have to solve here, put minus and then minus here. Then 2x get cancelled. Then 3y equal to 3a. Then 3 get cancelled. Y equal to a. In case if you are substituting y equal to a any one of the equation, for example, take the second equation. If you are taking the second equation, then we'll get the 2x plus y equal to 3a. Substituting y equal to a here, that is 2x. If you are substituting y equal to a here, a equal to 3a. So 2x, taking that a to that side, then 3a minus a will come. That implies 2x equal to 3a minus a. So what is 3a minus a? 2a. So in the next step, I am writing the 2x equal to 2a. Then 2 get cancelled. We'll get that x equal to a. So when you are solving this first order partial derivatives, we will get that x equal to a, y equal to a. Therefore, the stationary point is a comma a. To find that maxima and minima, next we have to find that second order partial derivative. What are the second order partial derivatives? Partial derivatives are f(xx), f(xy), f(yy). So simply we can write this as r s t. So what is fx is given? 2x minus 6a plus 2x plus 2y. So 4x, adding the 2x and 2x, 4x minus 6a and then plus 2y. Differentiate with respect to x again. We will get that only 4. The remaining things are 0. That is r value. Next, we will find that dou square f by dou x dou y, that is equal to 2. That is yes. Next, we have to find that dou square f by dou y square, that is also 4. So next, what is delta here? Delta is RT minus S square. What is the value of RST? That means second order partial derivatives and delta value at a comma a. First one is r is greater than 0 because r is already constant. R is 4. So when r is 4, no need to substitute any value in this. So already it is greater than 0. And delta value, all that r, st are constants. So when you are calculating rt minus x square, r is 4, t is 4 here, minus s is 2 square. So 16 minus 4, that is greater than 0. Therefore, when the delta greater than 0 and r is greater than 0, when the delta greater than 0, r is greater than 0, then if f of x comma y has minimum value at the point of a comma e. So f of x comma y as minimum at a comma a. So what is the minimum value here? Minimum value, what is f of x comma y given? F of x comma y given is x square plus y square plus 3a minus x minus y whole square. Substituting x equal to a and y equal to a, we will get that f of a comma a is a square plus a square plus a square, that is 3a square. So therefore the minimum value of f of x comma y at a comma a is 3a square is the answer for this problem. In the similar manner, we can discuss one more problem. Many times the same problem repeated in the university examination. See the question. In a triangle ABC, find the maximum value of cos A, cos B, cos C. In triangle ABC, A plus B plus C equal to pi. So we know that any triangle, if you take any triangle, three angles as given: A, B, C. Generally in the triangle, what is the addition of all the angles? That is 180 degree. That means pi. So that is given here. Once again, it is like last problem. We are going to find that the conditional extreme value for this. So we can find the solution here. Using this condition, we express the given function as a function of a and b. So how can we express this function as a function of a and b? How can we find this? That is, here condition is given a plus b plus c equal to pi. So we can write that as c equal to pi minus a minus b. Substituting c equal to pi minus a minus b, the given function becomes cos a, cos b, cos of pi minus a plus b. What is cos of 180 minus theta? Minus cos theta. Therefore, that f of a comma b becomes cos a cos b minus cos a plus b. Take it that minus outside, then minus cos a cos b cos of a plus b. So what is f of a comma b here? Cos a cos b cos of a plus b. To find the extreme value, first we need to find the first order derivative. Since what is the necessary condition for the maxima and minima? Fx equal to 0 and Fy equal to 0. So here Fx equal to 0 and Fy equal to 0 means first we have to find the first order derivative, dou f by dou a. So what is dou f by dou a here? That is given function differentiate with respect to a. So f of a comma b, keep it that cos b as a constant, then keep it cos a. What is d of u v formula? D u into v minus u into, not minus, plus u into dv. Using this formula you can find it. So first keep it that cos b, then cos b as a constant, then cos a, keep it that differentiation of cos a plus b is minus sin a plus b plus keep it that cos a plus b, differentiation of cos a is minus sin a. So cos a sin a plus b plus cos a plus b sin a. Once again it is in the format of cos a sin b plus sin a cos b format. So what is the formula for sin a plus b? Sin a cos b plus cos a sin b. Using this formula we can write that fa, that is dou f by dou a, as cos b into sin 2a plus b. In the similar manner we can find that fb. So what is dou f by dou b here? That is fb is cos a into sin a plus 2b. So after finding the first order derivative, we have to equate to 0. What is the necessary condition for extreme value? The first order derivatives dou f by dou a equal to 0 and dou f by dou b equal to 0. So what is dou f by dou a here? Dou f by dou a is fa, that means cos b. Here fa is there now. This fa cos b sin 2a plus b. So cos b sin 2a plus b equal to 0. Then fb. What is fb here? Cos a sin a plus 2b. Cos a sin a plus 2b equal to 0. Keep it this as equation number 1. If both the equations equal to 0, then what are the possible values? One is cos b equal to 0 or cos a equal to 0. Either cos b equal to 0 or cos a equal to 0. That is the first chance. Second chance is if cos b equal to 0, sin 2a plus b equal to 0 or a plus 2b equal to 0. Similarly, sin 2a plus b equal to 0, then cos a equal to 0. Therefore, the fourth one condition also is there. The fourth one condition, sin 2a plus b equal to 0, sin a plus 2b equal to 0. First condition, what is the first condition there? First condition is cos b equal to 0, cos a equal to 0. Cos b equal to 0 means b equal to cos inverse of 0, a equal to cos inverse of 0. When the cos is 0, cos inverse of 0 is pi by 2. So a also pi by 2. A is pi by 2 and b is pi by 2. So what is the point here? Pi by 2 comma pi by 2. Second chance. Second chance is if cos b equal to 0, b equal to pi by 2. Since if cos b equal to 0 here, b equal to cos inverse of 0. When b equal to cos inverse of 0, then b equal to pi by 2. Then we will look for the next chance. That means sin a plus 2b equal to 0. When sin a plus 2b equal to 0, what is b here? b is pi by 2. Substitute here. So this 2 get cancelled. Then sin of a plus pi. What is sin of pi plus a? Sin of pi plus a is sin of 180 plus theta. Sin of 180 plus theta is minus sin theta, because sin is in that third quadrant. In the third quadrant, sin is minus. Therefore, we can write that sin a. When that minus sin a equal to 0, a equal to sin inverse of 0. When a equal to sin inverse of 0, then a equal to 0 comma pi value. Similarly, we can find for third one. Just to interchange that, a equal to pi by 2 and sin 2a plus b we are going to find. So at the time a is pi by 2, b equal to 0 comma pi, because already we are getting b equal to pi by 2 and then a equal to 0 comma pi. In the similar manner, you have to find that a equal to pi by 2 and b equal to 0 comma pi. This is the third one case. Fourth case is sin a plus 2b equal to 0. First one, sin a plus 2a plus b equal to 0, or sin a plus 2b equal to 0. So 2a plus b equal to sin inverse of 0, a plus 2b equal to sin inverse of 0. That it may be 0 comma pi, 0 comma pi. So if it is both of them equal to 0, then we can, there is no meaningless, because we will get that a equal to 0, b equal to 0. Otherwise, we can go for the next chance. So what is the next chance here? Pi and pi. Therefore, we can take that 2a plus b equal to pi, a plus 2b equal to pi. So here we can write that the simultaneous equations, solving the simultaneous equations, 2a plus b equal to pi, a plus 2b equal to pi. How can we solve with this? If you multiple with 2 here, 2 into the second equation, we will get that, keep it the first one, 2a plus b equal to pi here. Then the second equation, when you are multiple with 2, what you get? 2a plus 4b equal to 2 pi. So put that minus, minus, minus here, solving this 2, the 2a get cancelled, and then 4b minus b is 3b, and then 2 pi minus pi is pi. Therefore, we are getting that b equal to pi by 3 here. When b equal to pi by 3, substituting b equal to pi by 3 any one of the equation, for example, taking this equation, 2a plus b equal to pi. If 2a plus b equal to pi, 2a equal to pi minus b. What is b here? Pi by 3. Substitute b equal to pi by 3 here. We will get that 2a equal to pi minus y by 3. That is 2a equal to 2 pi by 3. That 2 get cancelled on both sides. Then a equal to pi by 3. So what are the possible stationary points here? The possible stationary points are pi by 2 comma pi by 2, pi by 2 comma 0, pi by 2 comma pi, pi comma pi by 2, and 0, pi by 2, pi by 3, pi by 3. So here pi by 2, pi by 2, leave it. In case a is pi by 2, b is 0, then here that will not come, because in case a is pi means, then what about b and c? If a is pi, here also b is pi means, what about that a and b? So this is not possible. You can leave it. The other things we can take it. That is, only one value is valid here, because we can see the second order derivative here. In the second order derivative, fa equal to, first we take that fa equal to cos b sin 2a plus b. Next we are going to find that the second order derivative r. That means what is r here? R equal to dou square f by dou a square. That means dou f by dou a differentiate with respect to a again. That means cos b differentiate with respect to a, we will get that cos up to a plus b and then into 2. So 2 cos b cos 2a plus b, that is r value. S value, S is what? S equal to dou square f by dou a dou b, that means FAB, that is equal to, we will get that 2 cos of 2a plus 2b. Similarly, we can find that t value. What is t here? T is dou square f by dou b square. So this is in the format of cos a cos b. See that yes, here some typing is missing here. That is cos of 2a plus 2b. That is FAB. That is the value of S. Is it not? So at the point of a equal to pi by 2 or b equal to pi by 2, what is a value here? At the point of a equal to pi by 2, b equal to pi by 2, see the r value. Cos b is there. In case b is pi by 2, what happen? Cos pi by 2, 0. So wherever that cos a, cos b is there, then that will be 0. So when r is 0 or t is 0, the value will be getting minus. That means delta value is in minus. So delta is RT minus S square, that is less than 0. Therefore, there is no maximum or minimum value. So when that a value is pi by 2 or b value is pi by 2, there is no meaningless. Therefore, we can go for that only one point, a equal to pi by 3 and b equal to pi by 3. So a equal to pi by 3 and b equal to pi by 3 give the extreme point. At the point of pi by 3 comma pi by 3, what is r value? R value is 2 cos b cos 2a plus b. So 2 cos pi by 3 into cos 2 pi by 3 plus pi by 3. When you are substituting this, we are getting that r equal to minus 1. When r equal to minus 1, t is also minus 1. What about S value? S value is cos 2a plus 2b is there. That is 2 into pi by 3 plus 2 into pi by 3. That means cos 4 pi by 3. What is cos 4 pi by 3 here? 240. Cos 240 value is minus 1 by 2. Therefore, delta value. What is delta value here? RT minus S square. Then RT minus S square is minus 1 is R value, minus 1 is T value, minus 1 by 4 is S square value. So RT minus S square is 3 by 4, which is greater than 0 when R is less than 0 and delta greater than 0. F of a comma b has maximum value at pi by 3 comma pi by 3. So what is the maximum value here? That is 1 by 8. How can you get it that? 1 by 8. You have to substitute pi by 3 and pi by 3 in f of a comma b. What is f of a comma b? Minus cos a cos b cos of a plus b. That means you have to substitute cos pi by 3. A is pi by 3, b also pi by 3 here. Substituting a plus b, that means 2 pi by 3. So pi by 3 value is 1 by 2. Once again cos pi by 3 value is 1 by 2, and then cos 2 pi by 3 value is minus 1 by 2. So finally you are getting that 1 by 8. Therefore, the maximum value of f of a comma b at that point of pi by 3 comma pi by 3 is 1 by 8. Is the answer. Thank you. See you in the next class with the different problem.